I'm going to be talking about the different types of chemical reactions. So there are 5 general types of chemical reactions that we see, and they can be classified in a number of different ways. And it's the way that the reactants are interacting, the types of reactants, and what they're forming as a product. So what we're going to be focusing on are 5 different types, which is combination synthesis, which is literally combining 2 things to make one thing, or synthesizing something. Decomposition, which is taking one thing and breaking apart into many things. Okay? Single replacement, which you can guess is only one thing being replaced. Double replacement, which means 2 things being replaced. And combustion. You'll notice a little asterisk there, and what those represent are a type or a general type of chemical reaction called oxidation reduction. I've got a graphic here that shows the relationship. So if we just talk about the idea of chemical reactions, and if we want to break it apart, we can break it apart into double replacement and oxidation reduction. Oxidation reduction really has to do with the idea of transferring of electrons. So electrons are being moved from atom to atom and forming different compounds. And sometimes when those compounds form, they're actually making covalent bonds or possibly ionic bonds. And so combination synthesis, decomposition, single replacement, and combustion all fit under the idea of an oxidation reduction reaction, which is still a type of chemical reaction. Okay? So we're going to go in order here. I'm going to go ahead and start with the combination or synthesis reaction, which literally refers to the idea of 2 or more substances combined to form a single substance. Now, they can either be 2 elements, they could be 2 compounds, but the idea is that the product is always a compound. An example of this would, if we take potassium and react it with chlorine, we form what is called potassium chloride. Now, I'm hoping that you recognize here potassium is a metal and chlorine is a nonmetal. And because of that, this is actually forming an ionic compound. And you will notice that I have a very large 2 in front of the potassium and a large 2 in front of the potassium chloride because I'm balancing the equation. Okay? Now, a lot of people would ask, well, why is it that for the chlorine, the little 2 doesn't follow it over there to the product side? Well, when a chemical reaction occurs, it literally is a breaking apart, so bonds are broken, and then it reassembles itself to reduce its potential energy, right? So that's what's occurring. So if we look at it from a general standpoint, the general combination reaction or synthesis reaction can be looked at as R plus S yields RS, meaning that they're combining to form one. Now, if we look at the opposite of this, this would be a decomposition reaction. And it's when we take a single compound and it's broken down into 2 or more products. Okay? These reactions typically require some form of energy, whether that be in the form of light, heat, or electricity. Okay? And so usually we would signify that with a symbol above the arrow, such as a triangle or something like that to show that we're adding heat. But you can see here I have mercury oxide that is being broken down into mercury and oxygen. Okay? And again, I've balanced the equation with the coefficient in the front for the mercury oxide with a 2. And you will notice that we form 2 diatomic molecules. These are bonded covalently. And so if we look, the general equation would be Rs yields R plus S. It literally is the antithesis of combination or a synthesis reaction. Okay? So the next one we're going to talk about is single replacement. Okay? Atoms of one element replaces the atoms of a second element in a compound. I typically refer to this as the soap opera chemical reaction because we always have a character in a soap opera that is brand new, that sneaks in and swoops away someone who's been a couple for a very long time. So if we look at, we got magnesium here, and it's going to be reacting with zinc nitrate. And you can see on the product side that the magnesium is now with the nitrate, and the zinc is all by itself, meaning one thing has replaced the other. It's single replacement, okay? So literally, the magnesium is replacing the zinc, and the zinc is replacing the magnesium. Okay? We don't just see this with metals, we can also see this with nonmetals. So I've got potassium iodide reacting with bromine, and what we end up with is potassium bromide and iodine. So again, the idea is that the bromine is replacing the iodine. Okay, so if we look at this from a generalized standpoint, we have T plus RS will yield TS plus R, meaning one thing is replacing another thing in a compound. Okay, again, I kind of call this the soap opera reaction. Okay, the next one we're going to look at is double replacement. Okay, this is where both metal ions replace each other. There's no exchange of electrons. There's no change. There's no oxidation or reduction taking place here. This literally is a swapping of the metals in a compound. I typically refer to this as the wife swap chemical reaction. Wife Swap is a really bad show that came on at ABC a number of years ago, in which literally the wife of one family is replaced with the wife of another family, and they see how they interact for a week. And of course, they're polar opposites. So it's the same concept in the sense that right here we've got the zinc that is going to be replacing the sodium. And what ends up happening is we end up forming zinc carbonate, and we end up forming sodium nitrate here. And again, you'll notice that I've balanced the equation. Okay, so the general reaction here is that TV plus RS yields RV plus TS. Okay. Now the last chemical reaction, and it's probably one that you're most familiar with, is combustion. This is when an element or compound combines with oxygen producing light and heat. All right, and one such reaction is magnesium reacting with oxygen to form magnesium oxide. Now you look at this and go, this looks like a synthesis reaction. This looks like combination. And yeah, it can be classified as both. The reason why it gets classified as combustion is because it has oxygen there as the reactant. And when I say oxygen, I'm talking about O2. Oxygen reacting with a metal or whatever other substance it might be. And so we can also look at it from a hydrocarbon. This is what we typically use, are hydrocarbons in order to fuel things around our homes. Okay, and how we get our electricity is by burning fossil fuels. So here we have hexane reacting with oxygen to form carbon dioxide and water. And every single time we have a hydrocarbon, a hydrogen carbon compound reacting with oxygen, O2, it will always form carbon dioxide and water. I hope this helps you get a little idea of the different types of chemical reactions.